Across vast plantations, harvested banana stems remain as dense fibrous biomass, the natural raw source for industrial absorbent materials.
Each stem contains thick cellulose fibers and natural absorbent pulp, forming the primary organic.
After fruit harvesting, the stems accumulate in massive quantities, creating continuous biomass reserves destined for industrial fiber extraction.
Inside each trunk, tightly packed cellulose strands hold exceptional absorbency, making these discarded stems.
Collected in vast heaps, the raw stems await mechanical extraction, representing thousands of tons of untapped cellulose fiber.
Industrial harvesters gather the loose stems, lifting and feeding the biomass continuously into onboard systems for high-volume collection.
Onboard compactors squeeze out moisture and compress the fibers, reducing volume and preparing the biomass for efficient transport.
Compressed fiber is transferred directly into bulk carriers, enabling rapid, high-capacity loading for uninterrupted movement toward the processing complex.
Fully loaded carriers transport the condensed biomass in continuous convoys, ensuring a steady, industrial-scale supply to the manufacturing facility.
Transport convoys reach the mega facility, where automated gates and weigh systems register every ton before internal handling begins.
Gigantic twin-drum shredders grip the compressed fiber blocks, ripping them into coarse fragments to initiate controlled industrial breakdown. Rotary wash drums flood the shredded fibers with recycled water, removing soil, sap, and impurities through continuous mechanical agitation. High-capacity screw presses squeeze out excess moisture, compacting the washed fibers while thousands of liters of water drain away continuously. Continuous belt dryers force heated air through the fiber beds, rapidly evaporating remaining moisture to stabilize the material for refinement. High-speed hammer mills break the dried fibers apart, separating bundles into fine, uniform strands suitable for absorbent core formation. Infrared heat bonds the fibers and polymers together, locking the structure into a durable composite that maintains strength during absorption. Heated applicators deposit controlled adhesive patterns, ensuring every layer bonds securely without adding excess weight or rigidity. A continuous waterproof backsheet is laminated beneath the cores, creating a leak-resistant barrier that secures the absorbent structure. Ultrasonic welders fuse the layered materials through high-frequency vibration, creating strong, seamless bonds without additional chemical adhesives. Rotary die cutters stamp the composite web into exact pad contours, producing identical forms with continuous high-speed precision. Vacuum drums isolate each pad from excess material, transferring the products precisely while separating and discarding surrounding scrap.
High-speed applicators stretch and secure elastic strands, forming flexible edges that help the pad conform closely to the body.
Embossing rollers imprint controlled channels into the surface, directing liquid flow efficiently across the absorbent core during use. Heated compression belts seal the pad edges, permanently enclosing the absorbent core and preventing fiber loss during handling.
Automated vision systems inspect every pad, verifying dimensions, alignment, and surface integrity with high-speed optical precision.
Slot die applicators lay controlled adhesive strips onto the backsheet, preparing each pad for secure placement during final use.
Siliconized release liners cover the adhesive zones, protecting the bonding surface while allowing easy removal during application.
Automated folding assemblies shape and position the wings, ensuring consistent geometry and proper fit for secure garment attachment.
Pressurized steam sterilizes every unit, eliminating microbial contaminants and ensuring hygienic safety before final finishing and packaging.
High-capacity chillers rapidly reduce temperature, stabilizing the sterilized pads and preparing the materials for precise downstream handling.
Dynamic weigh stations measure every pad instantly, fine-tuning mass and density to maintain strict consistency across the entire production run.
Rotary brushing systems soften the top sheet surface, enhancing comfort by raising microfibers and creating a gentle, textile-like finish.
Plasma treatment activates the surface at a microscopic level, enhancing wettability so fluids spread quickly and absorb efficiently.
High-speed robotic pickers position each pad precisely, aligning products into uniform arrays for efficient downstream processing and handling.
Indexing drums regulate spacing, synchronizing every unit into a continuous, precisely timed stream for the next processing stage.
Precision platen presses standardize thickness, compressing each pad to exact tolerances for consistent comfort and predictable absorption performance. Rotary trimmers refine the edges, while industrial vacuums extract loose fibers, delivering clean contours and debris-free product surfaces.
Ionized air neutralizes static charges, preventing particle attraction and ensuring each pad remains clean and easy to handle.
Automated testers dispense calibrated fluid volumes, verifying absorption rate and retention capacity to guarantee consistent hygienic performance.
High-velocity air knives remove surface moisture instantly, restoring each pad to a dry, stable state for continued processing. Servo-driven rejectors instantly remove defective units, ensuring only verified, compliant pads proceed through the continuous production line. Ultraviolet arrays provide secondary sterilization, neutralizing remaining microorganisms and reinforcing hygienic safety at high production speeds.
Precision spray systems apply a light conditioning and antimicrobial treatment, enhancing freshness while maintaining strict hygienic standards.
Continuous belt presses stabilize the laminated layers, locking density and shape so every pad maintains consistent structural integrity.
Micro-perforation drums create breathable channels, improving airflow and comfort while maintaining the pad's absorbent performance. Automated edge formers roll and reinforce the sides, strengthening containment while preventing leakage along the pad boundaries.
Deep embossing forms distribution channels, directing fluid quickly across the surface to maximize absorption and prevent localized saturation.
Ultrasonic weld points permanently lock the formed edges, reinforcing structural strength and preventing layer separation during use.
Vacuum stabilization pulls absorbent particles deeper into the fiber matrix, ensuring even distribution and preventing internal shifting during use.
Controlled thermal conditioning relieves internal stresses, allowing the bonded layers to stabilize and maintain consistent shape and flexibility.
Integrated flex testers repeatedly bend each unit, confirming elasticity and structural durability under simulated real-world movement conditions. Airjet cleaners remove residual lint and micro debris, ensuring each pad surface remains pristine before final downstream processing.
Target applicators add controlled adhesive to the wing sections, enabling secure garment attachment while maintaining overall pad flexibility.
Continuous pressure setting activates the applied adhesives, ensuring firm bonding and permanent layer stability across every pad surface. Laser calibration systems verify dimensions and alignment, automatically correcting positioning to maintain strict. Seated platens set the final form, compressing each pad momentarily to establish stable thickness and long-term shape retention. Ultrasonic welders fuse the outer layers together, creating clean sealed edges that prevent leakage and strengthen the pad structure. High-speed vision systems scan every unit for defects, verifying surface integrity and seam precision with microscopic accuracy. Defective pieces are automatically removed by high-speed robots, ensuring only compliant products advance through the continuous production line. Laminar sterile airflow removes remaining contaminants, maintaining a controlled hygienic environment before final protective treatments. High-energy ultraviolet arrays sterilize every surface, neutralizing microbes and ensuring each pad meets strict hygienic standards. Micro-dosing nozzles apply a controlled neutralizing mist, enhancing freshness while preserving the pad's absorbent performance. Controlled thermal conditioning stabilizes moisture and adhesives, allowing each layer to cure uniformly for lasting structural integrity. Automated lane synchronizers organize the finished pads into precise spacing, preparing consistent flow for the next high-speed operations. Continuous integration drums align and compress the output into uniform arrays, creating stable batches for advanced downstream processing. High-speed rotary dies separate each pad from the carrier web, delivering clean edges and exact dimensions at continuous industrial scale. Optical counters and robotic gates organize the output into precise quantities, forming uniform batches without slowing production speed.
Precision compression evens the stack height, stabilizing each batch for efficient handling and downstream automation.
Protective release liners are laminated onto the adhesive backing, safeguarding stick surfaces until the product is ready for use. Automated form-fill-seal systems wrap every pad individually, creating hygienic, airtight protection at continuous high-speed production. High-speed robotic pickers arrange wrapped units into exact stacks, maintaining alignment and rhythm without interrupting the production flow. Cartoning systems erect and load boxes automatically,
placing measured stacks into protective retail packaging with precise mechanical timing. Hot melt systems seal every carton securely, creating durable closures that protect the packaged products during transport and storage.
Dynamic check weighers verify the exact mass of every carton, confirming correct product count before advancing to final handling.
High-speed inkjet coders mark every carton with traceable data, ensuring complete identification and regulatory compliance.
Stretch wrap systems secure multiple cartons into rigid bundles, improving stability and efficiency for automated downstream logistics. Industrial palletizers stack bundled cartons into stable load patterns, creating uniform pallets ready for automated warehousing and shipment. High-tension strapping units compress and secure each pallet, locking the load into a rigid block for safe industrial transport. Stretch hood systems encase every pallet in a tight protective shell, shielding the products from dust, moisture, and handling damage. Print and apply systems mark every pallet with traceable logistics data, enabling precise tracking throughout storage and distribution. Industrial weighbridges and 3D scanners verify total mass and load geometry, ensuring every pallet meets strict shipment specifications. Compression systems simulate extreme stacking forces, confirming the pallet's structural stability for safe, large-scale logistics handling. Multi-point scanners confirm every barcode and RFID tag, guaranteeing full traceability and digital tracking across the entire supply chain. Industrial detectors screen every shipment for foreign contaminants, ensuring product safety and compliance before release to storage.
Automated audit robots perform final structural and visual inspections, verifying that every pallet meets strict quality and stability standards.
Before release, every pallet passes through a final sanitation cycle, eliminating residual contaminants to maintain strict hygiene standards. Automated systems attach certified documentation and compliance records, authorizing each pallet for regulated commercial distribution. Intelligent routing floors automatically sort pallets by destination, organizing outbound shipments with continuous industrial precision. Advanced vision systems perform final dimensional and wrap integrity checks, ensuring every pallet meets strict transport safety standards. Final authorization gates mark the completion of production, releasing certified pallets from the factory floor to the outbound logistics network.
Approved pallets enter the automated high bay warehouse, where intelligent storage systems organize inventory for rapid, on-demand dispatch. Automated retrieval cranes locate and deliver pallets on demand, enabling rapid order fulfillment without manual handling. Automated retrieval cranes locate and deliver pallets on demand, enabling rapid order fulfillment without manual handling. Outbound staging systems organize pallets by destination, assembling complete shipments for fast, coordinated loading.
Automated loading systems transfer pallets directly into outbound vehicles, accelerating dispatch while minimizing manual handling.
From raw fiber to finished shipment, every stage flows through a fully integrated industrial